Hey guys, ignore how scary I am, but look at my cute kitty cat. She doesn't want to be told what to do. Here. So, her name is Wolf. Yeah, a cat named Wolf. I know. That was my husband's naming, but anyway, I'm looking really scary today. But you know what, guys? I ain't fake, so you get to see me in all my glory right now. I know. Well, I invited you up here, but anyway, I'm going to pause this and take off the camera so you don't have to see any more of this. And also know that while I have Biggie Smalls at home, I have to keep him away from Wolf because she eyes him. So anyway, all right, I'll pause this, take off the camera. You're welcome. And then we'll get learning some Z-scores. Oh, okay. Of course, as soon as I hit record, she runs away. I decided that cats are like teenagers. You guys should relate to cats, right? Like they just do what they want when they want. And if you try to like control them, they're like, no, not about that life. Just not about that. Like, I mean, look at her right now. What is she doing? Hold on. She's just doing what she wants when she wants. If any of you have cats, you tell me if yours is the same. But anyway, okay. So now I'm going to pause. Then I'll come back. All right. I'm back. Well, probably to you, I never left, but it's been a hot minute. So anyway, we are going to talk about Z-scores now because we have been learning about the normal curve, the normal distribution, and how to estimate percentages. And anyway, we've just been really just learning how to use the normal curve. Okay. Well, Z-score is related to the normal curve, but and if you're in class, I would print this out. So all you have to do is just fill in these blanks, but I would write down all of this, but for sure write down the formula. So I guess it's up to you what you want to write down. But what a Z-score is? A Z-score is a value that shows how many standard deviations which we know that measures how spread out numbers are, right? That's what a standard deviation tells us about a data set. How many standard deviations a data value is from the mean or average. Sorry, I'm just going to always say mean, but hopefully by now you know that is the same as average. Okay, so if we're looking at a normal curve here, right? This is the average, say we're talking about height of people or height of females, okay? Then if your height falls right here, and then this means you have a Z-score of something because you're going to be so many SDs away from the mean. Well, if it's positive, if your Z-score is positive, then you're going to be up here. You're going to be above the mean. Okay. If you have a negative Z-score, like this first arrow I drew, then this would be negative. So it's going to be below the mean, which makes sense because that means if your Z-score is negative, you're below. If it's positive, you're above. If your Z-score is exactly 0, then that means you're right smack in the middle, which is the average. Oh, yeah, nice arrow. Anyway, the data value equals the mean. So if you're just right there, smack average of height, then your Z-score would be 0. Okay, so then the formula, how to find a Z-score, which this is really all you're going to work with today, or yeah, sorry, I'm actually recording this Sunday, so it sounds weird when I say today. So you're actually just going to use this formula for Monday and Tuesday, and then Wednesday I will teach you something else to how to use a Z-score. anyway, so the formula is the z-score equals the x value, which is like whatever we're looking at. So like if we're talking about heights of females like we were up here, then I'd put my height right there, or whatever height of whatever female I'm looking at, okay? Minus the mean, which is, there's that mu for the mean again, divided by the standard deviation. And there's sigma again for the standard deviation. Okay, so it's the x value. Sorry, that z is not very pretty. There we, not much better. Okay, so the z-score is your value you're looking at minus the mean divided by the standard deviation. And then that tells you how many standard deviations that value is away from the mean, right? So if you need to pause this video right now, write it on the notes, do that, because then I'm going to get to, well, why in the heck would we use z-score? Well, I'm going to apply this to real life and answering one of the questions, and maybe some of you don't even care about the NBA or watch NBA. I actually don't. I used to, but still, at least I'm not throwing out some stupid random numbers and where you don't even care about. This has some application. So who is considered the GOAT of the NBA? If you Google it, which I did, it says Michael Jordan. So, and that's because players have voted on that, right? So players voted him over LeBron and Kobe. Rest in peace, Kobe. Okay. What we're going to do though, is we're actually going to look at some different statistics from these three players. Okay. So we are going to look at, let me get the cool magic pen. So we're going to look at MJ, because I really hope it's MJ, but we'll see. You guys probably have your hope, or maybe you don't even care, but okay. So we have MJ, LeBron. Guys, this pen is so cool. And then we have Kobe. All right. So what I'm going to look at for this example today is I'm going to look at their average points scored per game. Now, the nice thing about z-score, well, hold on one second. It keeps going back and forth. Well, z-score, yeah, what is nice about it is that it just looks at the mean in the SD, and I gathered all the data from, oh my gosh, sorry you guys have to see me right there. I gathered all the data from what Google and other resources said were their best years. So I'm just looking at one season. So for MJ, I think I did 1990 to 91 season. Okay. LeBron, I looked at, I got to remember, because 2009, 2010. And maybe some of you know, and you're like, no, that's not their best season. But you know what? I already put the 200 numbers in, so we're going with it. We're not changing. And then this is 2002 to 03. You guys are like, I wasn't even born. And I'm like, oh, I remember this. That's sad. Anyway, okay. So now what I did is, and of course I'm doing this now. If you guys were actually in class, I would have you help me with this. So maybe you're glad we're not in normal school. But basically, oh, I closed that tab. I took the average points per game of, I think all of the players that had at least played at least 70 games. Because like some years, if I scroll down a little bit, oh, too far. Go back up. Like this year with Michael Jordan, there were actually 197 players that played at least 70 games, because they're not looking at the average points per game of a player that plays 10 games a season, right? So anyway, so I took all of that. So this season had a lot, but whatever. Okay. That's what I did. So you know what? You guys didn't really need to know all that, but I just want you to know what I'm looking at, where the numbers are going to come from. Okay. So then I'm going to go menu 411. I'm going to find this stuff. And if you guys had a calculator, I would totally have you do this with me, but you don't. So I'm just going to pause and do it real quick. Okay, so I just realized that I minimized this camera, but it probably kept recording my face. So I'm sorry if that was the case. I should have just went like this. Anyway, I'm going to X out. Hopefully that means you can't see me. Anyway, okay. So what I did is I found their average of points per game that year. I found the average of the NBA, and then I found the standard deviation of the NBA for that year. So then now by finding the z-score of each one of these, then we are simply comparing them to other players from that year. And that's why it will be so cool, because then when we look at their z-scores, because the game has totally changed, right? From 1990 to 2009, just like in any sport. Like you just can't say, oh, LeBron has the highest points per game for his best year, so he is the best as far as the average points per game, right? Because that may not be true. I actually don't even know, you guys. I'm just awaiting the results with you. So anxiously awaiting. I forgot to add that word. Okay, so then let me show you how to find z-score. Really, Wolf? Oh, I'm telling you, dang cats. Okay, so z-score for Michael Jordan is his X value, which was his average points per game, minus the average of his year, which was 12.42, divided by 6.63, which was the SD. Okay, so I'm just going to write that. I'm not going to put it in the calculator yet. And then the z-score here for LeBron will be his value, which is 39, minus the average, 12.07, divided by 5.69, which is the SD. Would you knock it off? Okay, and then we have Kobe. So his z-score for 2002 be his average points per game, which is 30, minus the average for that year, which is 11.9, divided by the standard deviation of 8.41. So make sure if you're using just like a calculator, you know, like on your computer or your phone, that you put this in correct, or it's, so if you're just using like a old school one, right? Not a cool one like we have. You guys miss those, I bet. Anyway, so if you're doing that, just make sure you go, so like I'm going to, for Michael, I'm going to go 31.5 minus the 12.42 equals, get that value, and then divide by 6.63. Otherwise, if you enter in all at once, well, I don't know. It just might divide only these two and then subtract it from 31.5, which is not what we want. Okay, so it looks like MJ's z-score, dang, I didn't even look at it, 2.877. So I'm going to write it down here. 2.877. Okay. So what about LeBron's? Ooh, don't go too far, calculator. LeBron's is 39 minus the 12.07. Get that. And then we go divided by 5.69. Ugh, LeBron. I was afraid of that. Okay, just kidding. 4.73. And then, oh dang, what am I doing? Okay, and then Kobe will be 30 minus 11.9, get that. And then we're going to divide that by 8.41. His is 2.15. I guess if I'm only going 2 decimal places on both of them, or all of them. Okay, so who is the highest above the mean for their particular year? Like who did the best for their time with average points per game? Because notice I'm just looking at that statistic right now. I'm actually going to have you guys look at other stats like rebounds or field goal percentage, or I don't know, whatever. I'll find some stuff. Anyway, so based off of the average points per game, LeBron has the highest Z-score for the average points per game. And I may have just chosen the wrong year. Like maybe if I chose different years for these guys, they would get a little bit higher Z-score, be higher than LeBron. I'm not sure. But I tried to pick what seemed like their best year for average points per game. But anyway, so LeBron did the best for average points per game. So like I said, I'm going to assign you guys. I will give you the data because, yeah, you guys, I actually put all here. Let me scroll over. I'll show you what I did. So yeah, I put all these numbers in, and like I couldn't even like copy and paste from the internet. I actually had to type it. But you know what? It's fine. If I wasn't a nerd, I'd be complaining, but I actually like it. So shouldn't say anything. Anyway, so I will actually give you the stats, like what they got, the average and the SD. And then you'll just have to find the Z-score for each one and then tell me who did the best for that particular stat. And then at the end of the assignment, based off of all of the stats, you'll say, who do you think is the GOAT of the NBA? Is it really who Google claims? Is it? We're going to find out statistically using Z-scores. So it's going to be fun. All right. Later. I'm going to stop this recording maybe. All right. Have a good day.